Good morning, students. Let us continue our chapter Work and Energy, and our today's topic is conservation of energy. After discussing what is energy, what are various types, what is mechanical energy, what are its types. Mechanical energy have two types, kinetic and potential energy. So till now we discussed about that energy. Today we are going to discuss about conservation of energy. So after discussing these concepts, at the end of lesson, students should be able to show understanding of conservation of energy, correctly distinguish situation involving energy conservation and conversion, and solve related problems. So let us start. Before discussing the law of conservation, let us ponder on some examples in which interconversion of energy is taking place. Like when a candle is burning, then what happens? Chemical energy stored in candle, it convert into heat energy and light energy. Chemical energy is also a energy type, and heat and light is also energy type. It means one form of energy is converting into another form of energy. Next is fuel. In fuel, chemical energy is stored, and when the fuel burns in oxygen, it produces heat, and this heat is used to convert in kinetic energy. Like in some engines, if heat is produced, it moves the vehicles, then it produces kinetic energy. Heat is converted into kinetic energy because of motion. Now, in some places, it is converted into electricity, like in um, electricity generators, where we burn coal and by which heat is produced, by which we boil the water, and the steam is used to produce electricity with the help of generators. Now, nuclear explosion. Nuclear energy is converted in heat and light energy. In spring, elastic potential energy is converted into kinetic energy because it moves. So we can see that some type of energy is converted into some other type of energy. That's why we can say law of conservation of energy, because according to this law, energy can only be converted from one form to another. It can neither be created nor be destroyed. Means the total energy before and after the transformation remains the same. Total energy remains same. Some part of it is converting to other form, but if we add up all the types of energy which is converting, the total energy remains always same. The law of conservation of energy is valid in all situations and for all kinds of transformations. Let us discuss this law of conservation of energy with the help of a freely falling object case. You can see in picture that an object in free fall means the object is falling freely under the influence of gravity. Let this ball is falling from a height. We are holding this ball and it is placed at a height and it is not moving. So at the highest position, the gravitational potential energy of this ball is maximum, and as it is not moving, so its kinetic energy is 0. But when this ball, this object start falling, then what happens? This gravitational potential energy go on decreases because its height is decreasing from this ground level. And as we know, gravitational potential energy is directly proportional to the height of object from the ground level. So its gravitational potential energy is decreasing, but since it gains some velocity, so its kinetic energy start increasing and total sum of energy remains constant. In the same way, it is coming down, and just a moment prior hitting to the ground, its potential energy is zero, but as it have gained a lot of velocity, so its kinetic energy is maximum when it reaches to the ground. Let us understand this case with the help of some numerical values. Suppose at this height, the object, this ball, is having energy equal to 10 joule. So that 10 joule energy is in the form of potential energy only. So at this position, potential energy 10 joule, kinetic energy 0. Suppose we consider at another position here, as its height is less and its potential energy decreased. So suppose at this point, at this position, its potential energy is 4 joule, and as it have gained some velocity, so it have kinetic energy, and suppose here the kinetic energy is 6 joule. So 4 plus 6 joule, total will be 10 joule. Here also the total energy of this object was 10 joule. Here also it is 10 joule. Now at the ground level, when it reaches here, so just one moment prior touching here, the potential energy becomes almost zero, but as velocity is increasing, so kinetic energy will be 10 joule. So 10 plus 0, again total energy will be 10 joule. So in this way we can understand that total energy remains constant at every place. And in this situation, in this example, we are considering that air resistance or loss of this energy to the surrounding is zero. We are assuming this. No doubt it's not zero, but still some energy is converted into the motion of these air particles and more, but that is very small, and while discussing we are neglecting that conversion of energy. In the same way, we can understand this law of conservation of energy in a pendulum, and this is your NCERT question number 15 also. In pendulum also, law of conservation of energy is following. Actually everywhere this law of energy is followed, and let us discuss in this case. Suppose this is a pendulum, as it is at this rest position, and its ground level is considered from this point. So at this ground level, its height from the ground level is 0. As we discussed, that potential energy depends upon the reference level we chosen, and we choose the reference level this height. So here its height is 0. At this place, as at the initial stage it is not moving and its height is 0, its energy, mechanical energy is 0. Now what we do, we hold this object, this ball, and we take it to a height. Suppose we take it at this height. It means in doing so, what we are doing? We are doing work on this object, and that work is converted or stored in the form of potential energy at this position, at C position. So at C position, what is happening? Highest point of swing means this was the ground level, seen another picture, and height from this ground level is h. So maximum height, so maximum potential energy at this position, but still we are holding it in our hand, so its velocity is 0, it is not moving. So at this position, its kinetic energy is 0 and the energy is in the form of potential energy only. From where that energy comes? Because we have done work in lifting this object to this height. That work is converted in the form of energy. When we leave it, it will start moving towards its mean position. These are extreme positions and this is mean position. So as it is moving towards mean position, its height is decreasing from this ground level. Here, its height is decreasing. You can see height is decreasing. As height is decreasing, its potential energy is also decreasing. But as it is gaining velocity, so its kinetic energy is increasing. But total sum of energy remains constant when it reaches to the mean position. Now what is happening? Its velocity becomes maximum, but height from the ground level is 0. So potential energy becomes 0 at this position, but kinetic energy becomes maximum, and due to inertia of motion, it crosses this position and reaches to other extreme height. Now, as it is going against gravity, so the velocity of object go on decreasing. So its kinetic energy go on decreasing while going towards the B, but its potential energy going on increasing because of increase of height, and at point B it become 0. Velocity becomes 0 because it comes to rest for a moment. So at point B, its kinetic energy becomes 0, but due to maximum height, its potential energy becomes maximum. And in this way, the same procedure go on repeating. So in this case also, the total sum of energy at every point becomes same, remains same. That's another thing, that kinetic and potential energy go on interconverting to each other depending upon the position of the object. Now another question in this question number 15, it's another part is that why if it follow the law of conservation of energy, then why this ball come to rest after some time, it go on moving and finally comes to rest. So that is because its sum of energy is transferred to the air particles, and those air particles start moving. So that energy is converted in the kinetic energy of the particles. So the total energy remains in the universe. It is constant, but it can change from one form to other form. Now, assignment number 1 I have given you already with the topic work. This is assignment 2. Question number 1. A ball of mass 1.5 kilogram is moving with the speed of 20 meter per second. So mass is given, speed is given, find its kinetic energy. Directly formula based question and you will get this answer. You solve this question and match your answer whether it is correct or not. Now that's why I have written answers also along with the questions. An athlete weighing 50 kg has 100 joules of kinetic energy. Now here what is given? Mass. Mass is given and kinetic energy is given, and calculate his speed. This will be the answer. So mass, weighing word, don't get confused by this weighing word. Actually mass is given. So it is also a directly formula based question. Question number 3. What energy conversion take place when an arrow moves from a bow? We already have discussed it with the topic that while a arrow goes out of the bow, then your muscular energy is converted into kinetic energy of the arrow. So we'll write muscular energy to the kinetic energy. Muscular energy is converted into elastic potential energy. You have to write 3 steps actually. So muscular energy you are supplying, and this changes the shape of that string, due to which this muscular energy is converted into elastic potential energy, and when arrow goes out of the bow, then that elastic potential energy changes into kinetic energy. Now question number 4, a car and a truck are moving with same velocity of 60 km per hour. Now here velocity remains same. Which one has more kinetic energy? If velocity is same, just recall the formula of kinetic energy, that on which quantity kinetic energy is depending. It depends upon mass now, because velocity is same. So you can easily guess which will have more kinetic energy. Of the vehicle whose mass is more, that is truck. If we lift a body of mass 7 kg, mass is given, vertically upward 10 meter height is given. Then calculate the force required to lift the body. So directly we have to find force, and beta, if we are talking about the force in lifting the body, so just recall that concept of weight in chapter number gravitation. Weight is the force with which earth attracts an object towards its center. So here the formula for force will be the formula same as for the weight, and weight's formula W is equal to mg. G is also given you for simplicity, take it 10. So this will be the answer. You have to solve the questions properly, write the given statement, then solution, write the solution and write the formula, and then put the values in formula and calculate the answers. Assignment number 3. What will be the kinetic energy of a body when its mass is made 4 times and velocity is doubled? So, as we know, kinetic energy is directly proportional to the mass. If mass is 4 times, so we multiply the value with 4, and if velocity is doubled, kinetic energy is directly proportional to the square of velocity. So 2 square is 4, and 4 into 4, it will be 16 times. So do this question. These type of questions are very, very important as per your exam. Question number 2. What should be the angle between force and displacement for maximum work? So beta, while discussing the work, we discussed that the angle can be 0 or 180 or 90 degree. Then in when 180 degree means in obtuse angles, the cos value was negative, and in case of acute, the cos value was +1, positive. So maximum value of cos you will read in 10th class, that is +1, and minimum is -1. So +1 value is when the angle is 0. So its answer will be, the angle will be 0 for maximum work. An object is dropped from a height h, when is its potential energy maximum and kinetic energy maximum? So as we discussed today also beta, when the object is dropped from a height, so at the highest position its potential energy is maximum, and at the ground level its kinetic energy is maximum due to maximum velocity. Question number 4. Name the appliances which work under the following energy transformations. Sound energy into electrical energy. So, in which instrument sound energy is converted into electrical energy? Just recall your general knowledge. Yes, that is microphone. In microphone, it converts sound energy into electrical energy. Second question, heat into mechanical energy. So in automobile engines, what happens? if petrol is filled in there or some gas is filled there, what is happening? A spark is produced and it produces heat. And due to that heat, that steam, the automobile vehicle, the tire of a automobile vehicle, means some changes takes place there, and by which it start move any vehicle. So the heat energy finally converted into kinetic energy. Kinetic energy is the type of mechanical energy. That's why we can write its answer as the automobile vehicle. Question number 5 is bus and truck have same kinetic energy. Now it is the reverse of that question. Which one of two is moving fast? Now the kinetic energy is same and bus and car have different mass. If their kinetic energy remains same, it means who is moving fast? Just guess yourself and write its answer yourself. I'm not going to give hint, it's very simple. Okay, so do these answers of assignments in your fair notebooks also along with the notes of the topic, and learn these notes and topic. I'll announce test and will tell you the date of the test. So thank you, all the best.